Good morning, everyone. Thank you for joining us today. My name's Nikki Kruger. I'm the Director of Marketing and Business Development with Santa Fe Indoor Air Quality Solutions. I got David Treelevin with us, who will introduce himself here shortly. We're going to be discussing the Inflation Reduction Act, energy efficiency, and dehumidification trends. You will notice down in the control panel, towards the bottom in handouts, you should see one of 5. We have uploaded a summary of this presentation for you to be able to download and use. If you do have any questions, please post them underneath the questions tab there under the control panel, and we will get to those at the end. We should have time. Other than that, I will hand it over to David.
Thanks, Nikki. And if you can monitor the questions during this, because I'm gonna have to minimize that panel to make sure I know what I'm doing.
Absolutely.
Awesome. Thank you. Yeah, so I'm David Treelevin. I'm the principal at Loblolly Building Science. Loblolly Building Science is a HVAC and building science consulting firm that works with product manufacturers and builders to improve the performance of their products and or systems. I do technical consulting, not tax law or government programs. So I'm not going to claim to be an expert on the IRA, but I have experienced and worked in programs that were very similar during the ARA funding and with utilities in some cities. So we'll get started. So generally, what is the Inflation Reduction Act? It was signed into law on August 16th, 2022, and the White House says that the act aims to help the United States meet its climate goals and strengthen energy security, invest in creating good-paying jobs, reduce energy and healthcare costs for families, and improve upon the tax code. A large portion of this funding is going towards the built environment. So there's a lot of funding that we have seen earmarked for R&D for cleaner technologies, replacing dated infrastructure, solar and EV tax credits and rebates, building energy retrofits, and on the new construction side, we're seeing tax credits incentivizing building above code. And recently, there was also some money that was earmarked for advancing state and city building codes, which we'll also see come into play. If you were in this industry during ARA funding under Obama, there was also a lot of money for the built environment. The IRA money is about 10 times the amount of ARA funding money. So a lot of money out there for this sort of work. So what are today's topics? So we're going to cover 4 of the IRA programs and potential pitfalls within them from a technical point of view, go through an IRA retrofit example, discuss crawl spaces, just because they are an item that may be retrofitted in this, and sort of talk about a couple things that you need to know with those. Talk about potential for moving targets during the IRA funding period, which is 10 years long, and then review everything with a summary. So IRA programs. So there are 2 types of programs that are outlined in the IRA that we're going to discuss: the federal tax credit programs, which is 45L, 25C, and 179D. 179D is the commercial energy upgrade program, and we're not going to discuss that in this webinar, but if you're do commercial work as well, it's good to know it's out there. And these tax credit programs can be used retroactively. On the other hand, the rebate programs cannot be used retroactively. And the 2 programs we'll talk about is the High Efficiency Electric Home Rebate Program and the Homes Act. These are going to be implemented by state energy offices. And originally, we thought we were going to have guidance from the state energy offices at the end of this year. However, most of them have updated their websites and now say it's going to be in 2024 sometime. So diving into our first one, we're going to talk about 45L, which is a tax credit that incents Energy Star and zero energy ready homes. 45L will give tax credits to Energy Star and zero energy ready homes for single and multifamily, either to the builder or to the owner, not to both. Some new guidance was recently released last week with the versions that are going to be incentives and how to sort of file the paperwork to get the tax credit. I want to point out that multifamily is two-tiered, one for non-prevailing wage and one for prevailing wage. So, what is prevailing wage? If you haven't heard of it before, prevailing wage is basically a minimum set of total benefits that are given to workers on the project. Prevailing wage is typically set federally, but states can go above and set a higher prevailing wage based on sort of what is a good paying wage for the type of work that's being done. Just so everyone knows, most federally funded projects that require things like Davis-Bacon Act will also require prevailing wage. So if you're working on a tax credit project or something like that where you're doing Energy Star or Net Zero Ready, you're probably going to be in this bucket of tax credits. This is likely going to be a review, but it's worth going through because we have a mixed audience today. But without going into too much detail, Energy Star is run by EPA. It's a program that requires properly installed and sized mechanicals that include ventilation, third-party testing and inspections to ensure good installation of the systems, both in terms of the envelope and the mechanical, and it allows for performance-based trade-offs. The target SEER and HSPFs are in the table here. This has recently been updated to SEER 2 and HSPF 2. We're sort of in that weird stage where we're seeing both SEER and SEER 2. So I just listed the SEER and the HSPF, but know that if you go on Energy Star's website, you can see the new requirements. They appear to be in line with the technologies that would be represented by these. So nothing really will change with Energy Star. DOE Zero Energy Ready takes into account Energy Star, but improves on the performance in order to capture all the low-hanging fruit before solar is added to the home. So these are solar-ready type houses. DOE also requires that the Indoor Air Plus program be met, which requires sealed crawl spaces if you have a crawl space, and also that RH be kept below 60% if you're in warm, humid climates. It should be kept below 60% no matter where you are, but it specifically calls out warm, humid climates. Table at the bottom, once again, showing the target SEER and HSPF, and these have been updated by the program as well to show SEER 2 and HSPF 2.
Hey, David, can you explain HSPF?
Yeah, heating seasonal, it's the heating side of SEER. So, SEER is a certain metric to basically look at the entire cooling season and determine an efficiency. HSPF is that on the heating side.
Okay, and was it last week there was something that actually came out too about for the credits that there has to be certification on every single project?
Yeah, I did not read up on that yet. Okay. So I'm, someone in the audience can answer that. That would be great.
Yeah, I have seen that. I mean, again, this is constantly evolving. So every week we're seeing more and more coming out about actually being able to receive these credits. So make sure that you're always aware of the latest and greatest.
Yep, good point. So, as we think about house as a system and doing our due diligence to give clients the outcomes that they expect and want, we're talking about potentially if we're moving from code to Energy Star or Zero Energy Ready to take advantage of this tax credit, we're going to be making a lot of changes to houses and the way we construct them. So we want to know what the outcome is when we're changing things and think about house as a system. We want to make sure we have good outcomes. So one way to do this is to model them. So I went ahead and did a modeling study in BOPT that uses code as the base, and then Energy Star and Zero Energy Ready as sort of another two models to be able to compare the outcomes. specifically looking at Atlanta, Georgia. This table shows the mechanical inputs that I used, and I used the expanded performance data for a major manufacturer to input the performance data for each of these systems in. So let me start explaining sort of this output from the model. So the x-axis is the months of the year, and the y-axis is interior relative humidity at 75 degrees Fahrenheit. The blue line is code construction. The orange line is really Energy Star. It could also be net zero energy ready, or slightly, in that ballpark, because in Atlanta, to go from Energy Star to net zero energy ready, there's not that big of a jump. And then net zero energy ready is the gray line with the dehumidifier. So we see that as we advance from code built to above code built programs, that we typically see an increase in interior RH. And this is because typically we're reducing the sensible load at a greater reduction than reducing the latent load. And then, so we have less AC runtime in terms of this, and then the higher efficiency equipment gives us higher operational sensible heat ratios, which also mean that we do a poorer job at removing moisture with that more efficient equipment in terms of sensible. To expand on this more, this graph, if my slide will advance, there we go. So this is the same graph we were just looking at in the top. I also added in two more graphs, so exterior dew point, and then this is latent cooling delivered by the HVAC system. However, because we have multiple different models up here, we're just going to use this to sort of tell us when the HVAC is operating. So the reason I added these bottom two graphs is to show you why we have sort of this consistent cycling of consistent relative humidity in the summer. And it's because we have high exterior dew points, high heat, and we have good cycling of AC and long AC runtime. So we have higher moisture, but we're balancing that out with higher removal rates. And so we see this sort of cycling around, for the code built without ventilation, we see it around 50. And as we add ventilation, tighter envelope, better, more efficient mechanicals, we see an increase in relative humidity. Whoop, my slides are going crazy.
Well, I think that's important to understand is all these programs are incentivizing tighter homes, mechanical ventilation, and more energy efficient HVAC equipment, which all results in less runtime, except for the ventilation, but less runtime of the HVAC system, which is the goal. Less runtime on the largest equipment in the house means energy efficiency. But we do have to add ventilation in. And so we do need to think about, I think in the past, when you had to think about using a dehumidifier, people thought that was a Band-Aid. And so somebody did something wrong. If I need a dehumidifier, somebody did something wrong. The reality is the way that our buildings are being constructed and the efficiency of our HVAC equipment and the need for ventilation, if you need a dehumidifier, you really probably did everything correctly, especially for shoulder seasons and overnight times when the AC isn't going to be running as much.
Yeah, so great point, Nikki. And to illustrate that, and another thing I wanted to point out about this is, so in the shoulder season, so in Atlanta, we have times where we have, mixed cycling of the cooling system. So we only see a little bit of removal, but we still have very high dew points, and we have low dry bulbs during this time as well. So we see lower AC run times, and this results in higher, high interior RH peaks during this time, unless we have a way to remove the moisture, which a dehumidifier is able to remove the moisture during this time, even though the AC is not running. And just to expand even more on what Nikki just mentioned, so why is the interior moisture high? As we move from a code built to Energy Star or net zero energy ready, we see better insulation, which doesn't impact the latent load at all. But it actually decreases the sensible load, which this says increase, which is wrong. Better air tightness, we see decreasing across the board. Ventilation, as we add back in ventilation because of this better air tightness, it's sort of a balancing act. We're increasing the sensible load and the latent load. And then higher efficiency ACs, we have excellent sensible removal, but we have poor latent performance typically with these. So what are some pitfalls of Energy Star and Zero Energy Ready if you're moving from code to one of these above code programs in order to get the 25C tax credits? The first one is sort of HERS score chasing. So the HERS index is the energy performance score. It's the miles per gallon for the house for Energy Star and Zero Energy Ready. And oftentimes we make decisions based on getting the score lower and lower to meet these programs. And we need to make sure that we're not just chasing the score, but we're also making good decisions for the home and the occupants. Poor ventilation selection. So blanket statements on ventilation systems across different climates and humidity zones are often made by product manufacturers, program documents, and increasingly by social media influencers who often are getting money from some of those product manufacturers. So we need to make sure that we're picking the right ventilation system for the right climate. And we also need to make sure these ventilation systems controls are appropriately functioning with our heating and cooling controls as well. Subpar HVAC selection and proper setup. So, typically to drive the score down and in these higher performance homes, we want to have higher efficiency equipment. A lot of the equipment that we're seeing that is higher efficiency, higher SEER, meeting these higher EER2s, things like that, do a great job at sensible removal, but they're sort of lacking a little bit more than our previous systems in terms of latent removal. A manual J is not going to show you, a manual J and S is not going to show you that you've selected the right equipment for the part load conditions. This requires some additional performance calculations and or modeling. That manual J and that S is selecting the equipment for the load 1% of the time. So the other 99% of the time we need to think about. And then lastly, non-systems thinking. So houses are systems, as we talked about before, made up of many different systems that interact with each other. And as we change one piece of one of those systems, it may interact with all the other systems that could lead us down a path we don't want to go down. So it's important to understand the impact of our decisions and how to safely navigate the changes to meet one of these programs. I don't suggest making tons of changes at once in the way you build if you're a builder. Small changes at a time, making sure that it's the outcome you want. But if you're jumping from code to Zero Energy Ready, it may put you in the other bucket and you may be at higher risk. So just make sure you do your due diligence there. All right, so the next one is 25C. That previous one is 45L. This is also a tax credit. It's a tax credit to incent energy upgrades and electrification. The maximum of $1,200 per year with an additional $2,000 when you add a heat pump or battery storage. I don't think Ford Lightnings are counting as battery storage in this, but there is a different program if you want a Ford Lightning to have a tax credit. 25C can be used year after year, like I said, and 25C can also be mixed with the rebate programs, and we'll talk about that later. So to qualify air source heat pumps under 25C, it's called out that they must comply with the Consortium for Energy Efficiency's advanced tier criteria. For the purple, these are the requirements for SEER 2, year 2, there's no requirement, HSPF 2, and then they have some sort of low ambient heating requirements as well. And then for the south, the orange section, we get rid of those heating, those low ambient heating requirements, but we add in the EER2 requirements, which actually is slightly tough for some manufacturers to meet for air source heat pumps.
David,
Yep.
quickly, what is EER2?
The energy efficiency ratio, and it's the new way that that's calculated. So it's number 2, and that's just an efficiency metric for cooling.
Okay, thank you.
It's like SEER, but it's a different calculation. So, what does all those criteria mean for 25C? It basically means that the CEE requirements are going to drive us to multi-speed and inverter equipment. Typically, this equipment has higher operational SEERs, and the control algorithms are really slanted at meeting that test requirement and getting the high SEER, high EER2. Some manufacturers are better than others in my experience with their algorithms to help control latent removal. But if your set point and your measurements are entirely based on temperature, it more than likely is not going to do a great job controlling humidity. This program, because of these requirements for these higher EER2s and SEER2s, is going to be more expensive equipment. And so homeowners are going to have to come up with more money up front because the credit is not going to cover the entire cost of the credit. It's not going to cover the entire cost of the equipment, and then also you're going to have taxes to use the credit against. So this will be slanted towards middle to middle upper class in terms of using 25C. So the above 2 bullets, really create a good opportunity for supplemental dehumidification in humid climates. But it will require HVAC contractors to sell this higher efficient equipment, talk to it, and then also talk to supplemental dehumidification at the same time. And this could be challenging for HVAC contractors who currently do not sell this type of equipment or sell dehumidification, but it is an opportunity for them to do so. So combining 25C is possible with the IRA rebates, as I mentioned. You cannot use a rebate and a tax credit to incentivize the same equipment. However, you can capture the savings in a rebate that come from a piece of equipment that is claimed under 25C. And we'll go through an example later with this so you understand it a little more, because that may be foreign if you're not up to speed on these. And I think, we may see some games played in terms of trying to space out over a retrofit spaced out over multiple years so a homeowner can claim multiple credits. This could present a big headache to a lot of contractors, but just know that because you can have the tax credit every year, you may see some clients reaching for that to be able to capture it twice. So 25C potential pitfalls, sort of covered this before, but selling to the money. So, if we're selling this high efficiency equipment to take advantage of the tax credit, we need to make sure that we're really thinking through what other things might come out of using that high efficiency equipment. If you're in a humid climate, it could be that you're not going to have the moisture removal you previously had on the older piece of equipment for various reasons, and that you may need to add supplemental dehumidification in order to keep the client happy. Existing homes with poorly insulated ducts who move from a single speed to a multi-speed system may run into condensation issue on the colder ducts, which may stay colder for longer periods of time. And this can be exacerbated if the ductwork wasn't sealed before and now it's becoming sealed, because before we were in a slightly conditioned space unintentionally, but slightly conditioned, and now we're moving further away. So we have a bigger delta from the air in the ducts to outside the ducts, which could lead to condensation. And then lastly, replacing just HVAC equipment and incentivizing that. When we're replacing HVAC equipment, it's always a good opportunity to bring the home up to date with the most recent research on human health. This means improved filtration, ventilation, and dehumidification, especially in green grass climates. So the next program, which is targeted at low to moderate income, unlike that previous program that I think is going to be more middle class to upper middle class, just based on the equipment and the tax credit aspect of it. So this is the High Efficiency Electric Home Rebate Act. There's a lot of words on this slide that you can read as I talk. It's a 10-year program. It's going to have a maximum rebate of $14,000 per unit. It's a lot of money per unit. There is an option to include supplemental dehumidification as a ventilating dehumidifier in the insulation, air sealing, ventilation section with the monies that are available there. And the program does only target low and moderate income based on area median income, as you can see down here. And moderate income only gets 50% of the rebate, so only $7,000 per living unit. Whereas if you're below 80%, you can get the total $14,000 for the rebate. Sorry, I'm having trouble advancing again. So potential pitfalls of this program, a lot of the same pitfalls that we saw before that we talked about. So poor ventilation selection, making sure that we're choosing the right system for the right project and right climate. Subpar HVAC selection and proper setup. So making sure that what we're selecting not only handles the sensible, but also the latent. And if it doesn't handle latent, think about adding supplemental dehumidification. And lastly, non-systems thinking. So, really looking at capturing that money and not thinking about the big picture in terms of how the systems interact and the outcomes that we may be creating. I want to caution everyone with this one because a lot of this money likely will be used in multifamily housing. And so when we create a retrofit package that previously may have just been for one house, this could be done to hundreds. So definitely make sure to watch out for these pitfalls, as it can get you in hot water really, really quick if you're not thinking through all the outcomes of what you're changing in these either units or houses. The last IRA program that we're going to cover is the Homes Act. So this is again going to be overseen by the State Energy Office and implemented. So we may see differences from state to state. And this is a program that is going to incent modeled energy savings over the base. So if you're on this webinar, you probably are already thinking what the pitfalls could potentially be. The biggest one is chasing energy savings to maximize that rebate. So not all energy saving measures always lead us to a good outcome. Sometimes they impact IAQ, especially if we're doing things like air sealing, duct sealing, and not thinking about ventilation. So, another aspect of it is that the modeling software that likely will be used, or modeling softwares that likely will be used, really only look at sensible BTUs in the calculations. They do take into account latent, but it's not as strong and put out, the savings as much based on latent BTUs. It's more on sensible. And so things like supplemental dehumidification typically are a big energy penalty because even though they may be required to maintain interior humidity, it's viewed as an energy user that doesn't have a benefit in these modeling softwares often. And with that being said, also, we all know indoor air quality things, added filtration, upgraded filtration, ventilation are typically energy penalties in these softwares as well. We discussed the other three in previous, so I'm going to keep moving in the interest of time, but it's once again, making sure we have the right HVAC equipment, not thinking about the outcomes and the interactions between systems, and not considering IAQ. And some of these may, depending on the states, what they end up doing, if they require indoor air quality to be considered with ventilation, if you're air sealing, that could be something a state energy office puts out there and may be a requirement. So it may not actually be a pitfall once the full programs are released. So we're going to jump through an existing home IRA example. So this is a real likely scenario of a retrofit utilizing IRA money. Pre-retrofit specs are on the left, and the post-retrofit specs are on the right. So we're increasing the attic insulation. We're dropping the building tightness. We're adding ventilation because we dropped the building tightness because it's something we should be doing. And then we're upgrading the heat pump as well. You know, as we're doing this upgrade, as we're thinking about this upgrade, speccing it out, we need to think about our changes in load once again. We need to make sure that we are taking care of that latent heat as we need to, and making sure the systems we're putting in are going to be able to do it. And often in green grass climates, this may lead us to putting in supplemental dehumidification as we think about this. So these are just guesstimates on costs based on what I've seen out in the market. These could vary greatly depending on what market you're in, but the actual numbers are not the point of this. It's to show you the amount of work being done and the ability to be able to use that 25C tax credit and the Homes Act rebate together. So, you know, if you're doing these things, you're going to be able to get the tax credit from the heat pump installation, which is 30% of the total cost, which almost always in those CEE advanced tier heat pumps, you're going to be maxing out this credit, which is $2,000. And then 30% on the insulation and air sealing would give you roughly $750 if you're using these numbers. And then for the Homes Act, we can model the energy reduction that is used, you know, that these help create. And, you know, if we model over 35%, we get $4,000. So, you know, in a quick model I did, this was showing 37% reduction in the market that I modeled it. And so basically, you know, if these prices are the prices you're using, you're getting $12,000 worth of work done, and you're getting $6,750 in tax credits and rebates to the homeowner. Pretty good deal, good way to layer. Definitely something that should be done if you're a contractor, is look at the maximum amount you can get homeowners, obviously. So the next question is, you know, will you need a dehumidifier? As sort of we just talked about, went through previous exercises, making changes to the house as part of the retrofit in humid climates, especially in the deep south, you're definitely going to want to have a dehumidifier, especially if you're seeing energy reductions in the 30%, because those are mostly sensible energy reductions. And so we'll restrict down the amount of AC runtime. Let's see what else here. Oh, and also in humid climates, another good thing to think about is if your client is looking to maintain 50% all the time, supplemental dehumidification is really the only way you can get there, unless you have some advanced crazy new system that's not on the market yet. So let's bring some data to this. So did a modeling of this exact same retrofit. I picked a deep south climate just to be able to show, you know, the difference. That's not to say in a humid climate you wouldn't see sort of these same numbers. However, it's not going to be as exaggerated. So this is the output, same format as the previous output. We've got months of the year on the bottom. We've got interior relative humidity at 75F on the left side. We have the pre-retrofit is in the red. And then if we were to do the full retrofit, it is in the gray there. And if we were just to do the HVAC, it's in the yellow. And then if we're to do the retrofit with a ventilating dehumidifier, it's in the blue line that you see hugging 50% RH. You know, the results show that the original pre-retrofit home was able in the summer to maintain around 50% RH. And now that we've done this energy retrofit, so we've reduced the sensible load of the structure, we may have added, you know, a little bit of latent in, but at disproportional numbers. And so we're seeing less AC runtime. We potentially also, with HVAC retrofit, have reduced the capability of the system to remove moisture by using a very efficient, sensible removal machine. So, you know, things to think about if you're going from here to here. Is a client going to be happy if you did this expensive retrofit that they paid about 50% out of pocket for, and you have left them with 60% RH in the dead of summer when before they were, you know, floating around 50%? I don't think it's going to be a happy client. So, you know, my suggestion in a situation like this is that supplemental dehumidification should be part of the package. It could even be included as a ventilating dehumidifier, and therefore the client is able to set the relative humidity where they want it and maintain it year round.
The shoulder seasons on there are blaringly obvious, right? With that relative humidity, there isn't, even in Houston where you have this, there's just not enough AC runtime to be able to handle the rainy seasons there, obviously.
Yeah, and a great way to think about this or look at this, if you know you're not into modeling or running calculations, is you can pull the weather data for free for a year, and you can look at the dew point versus the dry bulb and sort of make a guesstimate as to when you're going to have AC runtime and when you're not. And we know that interior dew point typically tracks with exterior dew point. And so if you have times where you have high exterior dew points and low dry bulbs where you're not going to get a lot of cooling, it's a situation where you could see big peaks like this, where you might want to put in dehumidification. So lastly, because we are talking about dehumidification, need to mention closed crawl spaces and crawl spaces in general. You know, they're going to be a big part of the IRA, especially in the Southeast, because they do show energy savings, and they address a lot of the IAQ issues that we want to make sure that we're addressing with whole house retrofits. So the first thing I want to mention is the drying mechanism. So the original research that was done by my previous employer, Advanced Energy, calls for 1 CFM per 30 square feet. This was determined by a series of field testing sites and modeling that was done in 2003. A lot has changed in construction since 2003. We've got more efficient equipment being used. We have single stage versus multi-stage, much more prevalent. And we have a lot more OSB being used in these crawl spaces, especially when it comes to I-joists. You know, a good friend of mine, Danny and Goff, and I have talked recently about this, but it's like half the I-joists that show up on site already have mold on them, you know, in the webs, and the other half get mold before the house is completed. I'm not saying that this supply air drying mechanism won't work, but I'm saying that the research that it's based on is dated, and the safer alternative is to use supplemental dehumidification, which is now in the IRC. So you can use supplemental dehumidification per the IRC.
What I think is interesting is if you just look at the last data that you had with the inside the house and how high the RH is, if you take that same strategy and put it below the home, you're not getting the AC runtime anymore that you used to be able to put that cooler, drier air into a cool space already, which drives the RH up alone. But we just don't get the runtimes we used to when that was part of, you know, initially part of code.
Yep, great point. Yeah, reduced run times, lower, you know, lower latent removal by the HVAC system. Yeah, definitely plays into it. The other thing I wanted to mention that in a lot of the programs that I looked at in ARA, we saw a lot of was replacing AC systems in vented crawl spaces in the South. You know, I hate taking pictures in crawl spaces because I always crawl out and I'm like, oh, this is gonna be a great picture. I'm gonna use a bunch of presentations, and then I look at it and it's fuzzy and you can't really tell what's going on. This is one of those, but it's one of the better ones. So hopefully you can see on the bottom of the supply plenum, there's little water drops here, and then there's water drops all along the bottom of the air handler. If you were to be able to see this well, you'd see that the whole air handler and supply plenum is sweating. And this was, you know, an incentivized heat pump change out in a vented crawl space. And what happened was they took out the original heat pump and put in new ductwork and this new heat pump. And they took the crawl space from being a vented conditioned crawl space to a vented wet crawl space. And it was slightly conditioned before because of the amount of duct leakage that was in there. So this is my plea to ensure that if you are an HVAC contractor and you're on this webinar, think about changing out the systems and how you're impacting the space around your systems, because you could be taking them, you could be taking that ambient space that is actually being cooled by duct leakage, and you doing a good job with your install could actually be creating a problem. So doing the right thing could be creating a problem because you're not thinking overall about the impact at the end. So, if you're replacing HVAC equipment in a vented crawl space, my suggestion would be to also include the closed crawl space as part of that package as well, to make sure that you don't run into this situation at the end and have to fix it in some way. So potential for moving targets during the IRA. I mean, this is a 10-year program that is, trying to change the built environment. Once again, it's advancing very slowly. So there are lots of things that are going to change in the next year. These are things that are within sight that we know are going to be changed. So ACA Manual S, a new Manual S, was just approved and will be out, I'm guessing, by the end of the year or start of next year. There's a lot of changes in there, and there's a lot of changes that could lead us towards dehumidification, because it's going to allow us to size to the heating load instead of the cooling load, and then adding in supplemental heat to make up for the difference there. So, if you're sizing the heating load and you're in a humid climate, you're going to have a way oversized cooling system, which will mean that you definitely need supplemental dehumidification. We're going to see A2Ls come into play, and then the SEER2 metrics are already well on their way, which will impact a lot of the programs in terms of Energy Star and efficiency ratings and things like that. EPA Indoor Air Plus that we talked about as part of Zero Energy Ready has been undergoing changes and public reviews over the last couple years. I think they're getting ready to release those. It's going to change it to a tiered program, which will be interesting to see if Zero Energy Ready latches onto that top tier, which will require a lot more. ASHRAE 62.2, I mean, if you looked at ASHRAE 62.2 10 years ago, it looks pretty similar, but there's a lot of changes to current. So in the next 10 years, we'll see changes as well as more research comes out and more research is done on indoor air quality in houses. Currently one thing is a proposal to limit interior moisture levels that has some steam behind it. Not sure if that will get accepted or not, but no, that's there. And then, just programmatic changes as we go through. So building code will change. We know it's going to be incented to change by IRA, and therefore Energy Star and those above code programs will have to change as well. And then lastly, there may be changes to the actual IRA programs, either by the state energy offices or by the feds, depending on how much money is left and free ridership or double dipping with different programs. So lots of changes. These are the ones we're seeing now. I'm sure there's going to be a lot more in that 10-year period while this program plays out. So just here's a summary of what we've gone over today in terms of the IRA programs and the applicability of dehumidification. We've got our programs here, the incentive types, so tax credits and rebates, and then just high level, the basics of the program. And then is dehumidification applicable? 45L, yes, it definitely is in terms of ventilation and meeting Energy Star and Net Zero Energy Ready. However, we saw through the modeling and what was discussed that yes, dehumidification is highly applicable to all these programs if you're in a green grass climate. And we need to make sure that we're balancing that latent gain to latent removal. And if we don't have that latent removal and we're out of balance, things like, we need to look to supplemental dehumidification to get us back in balance, to make sure we're maintaining that interior RH for the homeowners. And I just want to point out, there may be some changes to these programs in terms of 25C and the Homes Act that say that you do need to include ventilation. I'm assuming that they're not going to include ventilation just with how they're structured in there, but they could have a provision that says you need to do ventilation and we're going to incent it in this way. So these could change as we see more and more material come out, and more guidance on these programs. So that concludes my slide deck here and presentation. Here's my contact if you have questions, and we'll also open it up to questions now. Nikki, do we have?
I think we've answered them along the way so far. So I don't see any new ones that have popped up. It's a lot of information to take in at once. So this will be, recording will be sent out to you. I think by tomorrow, you'll get an email with the recording. If you couldn't download that PDF that we have included in here, please let me know, and we can make sure to get that email to you. I'm hoping to have it on our website by the end of the week also, and hopefully it'll be included in the webinar email that you receive. So if there are no questions, oh wait, here we go. Are coming in. I'm a crawl space encapsulation contractor and don't offer any HVAC services. Are there any direct rebates credits that apply to encapsulation alone, not HVAC upgrades?
Yeah, so let me go back a slide. So, the Homes Act is a rebate program that looks entirely at modeled energy reduction. So, in the South, a lot of the advanced energy research and also a lot of the modeling software shows this as well, is that you see energy reduction through encapsulation of crawl space, especially if ducts are in the crawl space. So I do think there is potential for you to sell based on the Homes Act, and get your homeowners rebate money for encapsulating their crawl space and dropping their energy usage.
Yeah, I know that Ken Allison with IDI has been doing a lot of trainings, presentations on how insulation contractors can utilize the IRA program with crawl spaces, increasing air sealing, insulation, and adding dehumidification for those homeowners.
Yeah, that's great, and I'm sure that training's out there. I just thought of another thing that I glazed over for some reason. The other one that's directly applicable is 45L. So, if builders are moving to net zero energy ready, it requires closed crawl spaces. So it may be time for you to make the rounds again to your contacts with builders you don't work with to see if they're going to be moving to net zero energy ready, and if you can close the crawl spaces for them. So there's another avenue there as well.
Absolutely. I spoke at the International Builders Show last year and on vented versus unvented crawl spaces, and the amount of inquiries after, even to this day, from builders that were using vented and now are thinking maybe we shouldn't be doing this, and the warranty claims that they get on their homes for wood flooring, indoor air quality issues and stuff like that is definitely rising. So if you are an encapsulation contractor, please make sure that you are connecting with your new construction builders in your area, because it is something that I think they all want to learn more about. Can you discuss how ventilating dehumidifiers vary from ERVs?
Yes. So ERVs is an ERV is an energy recovery ventilator, so it's a balanced system. So it is typically exhausting, let's say 50 CFM of air, and at the same time, it's pulling in 50 CFM of air. And as those two air streams go through the machine, the energy from the air leaving or air entering is put into the other airstream, depending on the season. So it passively moves energy from high to low. So you have to have a delta in order to have an ERV work well. Whereas on the other hand, a ventilating dehumidifier is a supply ventilation system, so it is only bringing air into the house and pressurizing the house, and then the air leaks out through various different paths. But while that air is being brought in, if the interior RH is elevated, the ventilating dehumidifier compressor will come on, and as that air is mixed in the machine and then dehumidified, it will deliver dry air and dry down the house. So the difference is basically that ventilating dehumidifiers are actively removing moisture, so they can remove a lot of moisture, wring out a lot of moisture, and ERVs are passively transferring the moisture, which is basically limited by physics at about 50%. Some of the standards, the way they're written, show that they can go higher, but if you measure them in the field, they transfer about 50% of the moisture from the outgoing to the incoming air. And in research that I've done in the past, if you do not have a good AC system or a good way to control the interior RH, ERVs do not maintain that delta enthalpy or energy they need in order to get good transfer amounts in the humid months. And so you see inside and outside approaching each other because we don't have that delta that we need for ERVs to work well. And so typically in the projects I work on, if I put an ERV in the south, I also put a dehumidifier because we need to maintain that delta enthalpy for it to work well.
So yeah, and when we say ventilating dehumidifier, ventilation is the option. You don't have to use the ventilation aspect of it, but I think from the work that I've done with David is we know that the ERV typically it can help reduce, but it will always contribute to the moisture load in the house. And just to clarify, the ventilating dehumidifier isn't going to automatically dehumidify that incoming ventilation air because it has a high moisture content. What we care about is the moisture level or the RH in the living space. So it'll bring in that outdoor air, and then the controller inside the home will say, oh, we've hit that above 50% RH. Now we're going to activate the compressor on the dehumidifier and dehumidify the entire home. Because sometimes a little bit of moisture isn't going to affect the space or that relative humidity, but it's, we might get the AC runtime. So that's taking care of it, but it's when it gets above that. And that air that is coming through the dehumidifier for ventilation is mixing, as David said, with the return air from the house. So it's not delivering very humid, hot air directly into the home. It's mixing with the return air from the home and then being delivered. So it's building science in a hot, humid climate says that, a slight positive pressure in that house is a good thing. So, that's why we use that supply ventilation and with MERV 13 filtration as well. Let's see here. Who's responsible for the energy reduction modeling on the Homes Act?
Yeah, I haven't seen any talk of who's responsible for that or how it's going to be reviewed. Yeah, I don't even know the modeling softwares they're going to use. There's a lot out there that have been invested by DOE and some other people over the years. I showed a home energy score one, which was became a little popular during ARA funding. We could see that raise up again. My guess is they're going to have to allow some sort of HERS score to be utilized in this, because training up people on modeling software can take quite a bit. And there's already a bunch of people out there who know how to use rim rate and the other modeling softwares that are used for HERS scores. So I would think states are going to push it to that, but it's yet to be determined.
Does dehumidification mode on the HVAC equipment help address the moisture loads?
So different dehumidification modes operate in different ways. Some of them don't, some of the dehumidification modes don't allow for sensible control. So if it's a mini split, a lot of mini splits have a dehumidification mode where they will just look at temperature and constantly run at a low sensible heat ratio. And then as they're overcooling, they'll change the amount of the cycling time to try and make sure they don't overcool too much, but you can't set a temperature set point during that. So those are sort of out of the picture for me. On our,
I mean, the pitfall with that is it's just you can create really cold air and then potentially create condensation.
Yeah, I mean, there's always that potential if you're trying to dehumidify and you're mechanically cooling. You always have that potential, and even more so then, because to run that lower sensible heat ratio, you can have a colder supply air temperature. Some of the other ones, they work okay to a point, but they don't allow overcooling. And unless you have reheat in the system, which is really not prevalent on the market right now, you're limited to basically providing 2/3 of that cooling is going to be sensible and 1/3 can be latent. And that's if you're running a really cold coil. Most of them aren't that low, but that's sort of right around where you start to freeze up the coil. And so the cooling mode, no matter what, is producing, 2/3 of it is going to be sensible and 1/3 is going to be latent. And if you don't have a sensible load on the house, you're going to be overcooling it, and it's not going to allow the system to run anymore, because it doesn't want you to overcool and cause other issues like Nikki talked about with condensation surfaces and things like that.
What about using an HVAC system that has reheat?
Yeah, so you can use an HVAC system that has reheat. There's very few of them on the market in terms of actual refrigerant reheat. You can use electric reheat. The caution with electric reheat is if you are in a climate that requires a lot of dehumidification, the energy bills are going to be through the roof. If you're in a climate that doesn't require a ton of dehumidification, you may be okay. And it also has to do with the set point. I know some major manufacturers, or a major manufacturer that has reheat built into their unit, only allows you to go down to 60% RH as the set point, because they know below that they're going to get big complaints for energy bills. And I've actually been told by that manufacturer to not implement that strategy because of high energy bills. So, electric reheat, I thought it used to be outlawed by code. I can't find it in code anymore. But it's definitely something that, in my eyes, if I'm doing a high performance building, I want to make sure that I'm effectively using all my input energy efficiently. And dehumidification, using a dehumidification system, like from Santa Fe, is going to be, I don't know, anywhere, depending on the conditions, it's likely going to be 2 to 5 times more efficient than that electric reheat.
Yeah, there is Residential Energy Dynamics, RedCalc, has a really good energy usage calculator that's free on their website that I often use to show the energy usage of our dehumidifiers. So you can put in the watts of the dehumidifier, how many days of the year, how many minutes per hour it's going to run, and then you can put in your cost per kilowatt, and it'll give you an approximate of what it's going to cost you to run that dehumidifier. So, and it's often, jaw-dropping to a lot of people how energy efficient these dehumidifiers can be. Does using CO2 monitoring to control ventilation rates meet code, or do you have to stick with the calculated CFM required?
I am gonna say I don't know the answer to that. I don't know what is allowed by the IRC in terms of ventilation. And when I've read it, I don't see that there's an alternative path to monitor CO2 and do it. There may be in ASHRAE 62.2, I believe you can through one of the appendixes that are in there. But yeah, I would suggest asking someone else that has more knowledge on that.
Perfect. The website that I mentioned for that energy usage, someone asked what that was again. It's Residential Energy Dynamics. But I think it's REDCalc, REDCALC, and I don't know if it's .org or .com. But if you Google Residential Energy Dynamics, you should be able to find that website. All right, that's what we have today. Thank you everybody for joining us again. And if you do not receive the recording within the next 24 hours and you would like it, please make sure to reach out to me, as well as for that summary page, one pager that we have available also. So thank everybody for joining us and have a great day.
Thanks.